Hi, so we're on video 4, and this video is going to focus on the assessments and how to kind of implement this unit. In previous videos, we talked about the anchoring phenomena. We looked at the unit as a whole, saw where those questions that we generated in the anchoring phenomena, where they get addressed. In the storyline, we talked about some resources to help establish classroom norms and encourage student discourse, so that shy student who's hesitant about their different idea feels comfortable to share their thinking with the whole class. That's really important to help students learn together throughout the unit. And so now this video is going to talk about where the major assessments come in, the storyline, how they kind of build on each other, and the different kind of resources in the teacher's guide to help you in regards to assessment in this unit. So I'm going to click on the teacher's guide and go to page 284. So there's reference materials, and there's this whole section about the assessment system overview. As a pilot teacher, one of my kind of criticisms was with the OpenSciEd curriculum was that its assessment system was kind of weak, and they heard that criticism from the field test teachers and really beefed up their assessment system. And a lot of these assessments that are in the unit now weren't in the field test version that I taught. And so I'm really impressed with that OpenSciEd heard our feedback and really improved what had been kind of a weak point in the curriculum, I felt. So this document goes like, kind of does an overview of where the major assessments occur. So there's like a pre-assessment, kind of figuring out what the students know, what questions they have. The driving question board is kind of your main pre-assessment in lesson 1. And then in lesson 5, students take a formative assessment called cold lemonade on a hot day. And so at that point, you're kind of putting the pieces together from your previous investigations to show how your explanation of the cold cup phenomena has deepened and improved. There's also another assessment in lesson 6. And there's some rubrics for these assessments. And notice that a lot of these assessments are kind of formative, and that they come at like places where kind of the topics change, like there's kind of bends in the storyline. So at lesson 5 and 6 is kind of one bend, and then lesson 14 is another, and then lesson 18 is the last lesson. And that's where like kind of the summative assessment occurs. And so there's some scoring guidance and rubrics to rely on. But OpenSciEd doesn't give you like a specific grading system to use, since that might be so specific to your individual school or district. Do what works with you, what your rules are, but there's supports in the curriculum at these different points. There's also just kind of assessments that happen every day with every lesson. You can look at each teacher guide and see what the performance expectations are, and see if the students are meeting those. There's also a progress tracker, which students keep. Sometimes it's referred to as like the model tracker, where students are summarizing what they learned after each lesson. There's self-assessments that occur, especially during like discussions, to talk about how you followed the norms, or what did you learn. what starters are you going to try for the next discussion? And then there's opportunities for peer feedback as well. That's seen in lesson 16. They also kind of highlight for each lesson assessment guidance. So you can have assessment in each lesson. I won't go through all of that, but I want to kind of show you what the assessments look like so you can kind of have the end goal in mind as you teach these units. So let's start with lesson 5 and look at the cold lemonade on a hot day. Okay, so this kind of makes me think of, like, you know, the Page-Keeley probes where you have 3 students talking and you have to figure out which one you agree with and why, and support it with evidence. And you know, what you're asking students to do is really apply the data that they collected from their investigations in the previous 4 lessons to determine which claim has the most evidence. Okay, so that's lesson 5. And then lesson 6 also has another assessment where students are starting to look at what impact you know, changing the lid would have. And they're doing some more kind of modeling, looking at the particles. The students are given some kind of data and have to write a conclusion. So that's just a brief overview. I'll show you kind of what a rubric looks like. So here's kind of like the components of what the students should have in their models. There's a lot of like systems, you know, there's, you know, condensation happening. Students should be able to explain that at this point, what's occurring there. You know, these are the things that you should be looking for in their drawings, like how they've spaced the particles, you know, that what's going in and out of the system. So as the unit progresses, you're going to get more and more components and interactions and cause and effect in this rubric. So this is just kind of like a midpoint assessment to make sure that the students are with you and that they understand what they should at this point of the unit before you move on and talk about like what effect light has on heating and cooling, for example. Okay, so after another kind of bend in the storyline, we get to lesson 14. Where they're given this scenario about icing an injury, and they're given some data, and they have to, again, kind of do the sort of Page-Keeley thing where there's 2 claims and they have to figure out which one they support with evidence, who's correct and why. And there's some more kind of modeling, and we'll kind of see in the rubric of like what added features should be included in their model now that they've experienced lessons 7 through 12. So kind of showing their model over time. So let's look at the rubric. So we've added some components like how the particles are moving in different states of matter, how the particles move at different temperatures, how energy transfer happens between the systems. You know, and then here's this new part of the rubric, you know, the mechanism. So, you know, how does energy transfer happen to cause a temperature change? You know, focus on this idea of particle collision. So that might be something that they didn't have in their first model that now they should have by lesson 14. And so kind of the summative assessment is this one here. And this is kind of termed like a transfer task, where you take what they know about the cold cup phenomena and apply it to, and transfer that knowledge and apply it to a different scenario. And this might be like one of their related phenomena that they came up in lesson 1. And now they have to take what they know about the cold cup and apply it to a new scenario. So one criticism I've seen of OpenSciEd curriculum is that, oh, they're like so focused on this one phenomena, the kids get bored, they're tired of talking about the cold cup. One way you can increase engagement is to bring in the related phenomena. So it kind of gets students thinking that, oh, well, I'm not just learning about a cold cup for, you know, when I work at Starbucks one day. I'm actually learning about you know, thermal insulation, and this has a bunch of applications for when I'm, you know, insulating my home, or maybe I'm, you know, wanting to create a disaster kit for my family. Like, how do I design a blanket to keep me warm in case of an emergency? So they have a couple different models, and they have to kind of go through the same thinking process that they did evaluating the different cups with this new scenario, this related phenomena. And they've got some data to look through, and they have to explain, you know, their choice. I think this assessment also fits in really well in the 6th grade, because later they're going to be learning about natural disasters, like at earthquake at Mount Everest, and they're going to be learning about tsunamis. And so it fits kind of very well in the theme of later units, these disaster blankets. So those are kind of the main assessments that students are going to do throughout this unit. So you know, this 4 videos was just like a really quick, condensed version of, like, you know, I got like a 3 or 4 day training on how to teach this unit. So I'm trying to boil down it just to the essentials, but I want to point you to other resources that can help get your questions answered and give you, you know, new ideas about how to implement this. One place that's really helpful is the Facebook page. So there's almost 800 people on here, and it's a place to, you know, ask questions and get, you know, sample activities, extensions, bring a problem to practice, and get help from people around the country. So that's one. And then OpenSciEd like is pretty active on Twitter. So if you open up Twitter and search for OpenSciEd, you might see examples of teachers posting their driving question boards for this unit, or you know, photos of them doing a lab and stuff. So there's ways to connect with teachers on Twitter to increase your knowledge about the OpenSciEd units and look for new ideas. There's also a bunch of curriculum professional development on the OpenSciEd website. So if you go here to like professional learning, there are a bunch of materials, some of which I pulled, that talk about how to have just good discussions, universal design for learning. They have some webinars as well, and their YouTube channel. So there's a lot of great resources that are free on OpenSciEd's website that can you can kind of access as you need. I pulled from some of those to make this presentation. in Washington State, your educational service district is also a big supporter of OpenSciEd, and they can probably connect you with other teachers like me who field tested the materials or who have implemented the released units in their classroom. So those are a variety of different places where you can get some support as you try these units. So that's the 4 videos. Thanks for making it this far. I put a link to a course eval survey, so if you could fill that out, I'd appreciate it. Thanks for watching this, and feel free to connect with me if you have any questions about implementing these units. OpenSciEd is, like, in my 11 years of teaching, is the best science curriculum I've come across. They're working on elementary and high school units as well. So I think it's a great organization and great curriculum, and my students have really benefited from this. When I was my first year piloting the curriculum, like, I saw my students' test scores increase 11% from one year to the next. So it works. And the assessments that the students end up doing really mirror what our state assessment looks like, and are very rigorous and help them get prepared for passing the test and thinking deeply about science. So I hope you find this video helpful, and best of luck in the next school year. Take care.